Now, some great problems to solve using radicals are things involving the Pythagorean theorem. And as a quick review, the idea behind the Pythagorean theorem is you have a right triangle, a 90-degree angle, and the two sides are A and B, and the longest side is C. So again, remember, it doesn't matter how you draw the triangle, the longest side is always going to be C, and the other two, I don't really know what I was trying to do here, like that. The longest side is going to be C, and then the other two sides are A and B. It doesn't matter which one's which. The Pythagorean theorem is that A squared plus B squared is equal to C squared. Got it? So where this comes into play, with radicals at least, is that you can end up with something maybe like this. You have like 10m and 4m, and say, no, meters, it's supposed to be meters. 10, 4, and like x, and it says find x, okay? So I know that these two, the longest side is going to be C, and the shorter sides are A and B. Okay? It doesn't matter which one I put as which, as long as C is the longest side. So by A squared plus B squared is C squared, I have 4 squared plus x squared is equal to 10 squared. Right? So 16 plus x squared is equal to 100. Or x squared is equal to 84. And then taking the square root of both sides. Again, I'm not going to use the plus or minus because I can't have a negative length. Now all I have to do is reduce that 84. So I can say, well, I know there's a, let's see, the biggest number I can think of, it's a perfect square that goes into it. 4 will go into it, 9 won't. 16? Maybe? Probably. Oh, that's 64. No, I don't think so. I don't think 16 goes in there. 25? No, I'm just going to stick with 4. Alright, so I've got 4 times... Let's see. $21. Oh, yeah, 21's not going to do anything interesting. So I can pull out the 4, make that 2, root 21. Alright? So something kind of along those lines. Now we can make them a little bit more interesting for the purposes of doing this. So I'll draw a right triangle like this. And I could say, alright, this is going to be something like that. And then it would say find x. Okay? So again, I can label the longest side as C, and then the other two sides are A and B. So A squared plus B squared equals C squared. Okay? I'm going to go ahead and write these out so they're a little bit easier to FOIL. You know that's not a bad idea. Alright, so I'm going to first, outer, inner, last, first, outer, inner, last, first, outer, inner, last. So over here on the left, I have 2x squareds. I don't really mean to cross them out, I'm just trying to indicate that I've used them. I have 2x squareds. I have 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 4 and 9 is 13. I'm just going to kind of plug and chug, go to town. of all kinds of fun. Doop-doop-to-doo. Doop-doop-to-doo. Doop-to-doo. Alright, so I've got x squared plus 2x minus 3 is 0. So I'll FOIL that out. That's a minus sign. Right, so that means one's going to be a minus and one's going to be a plus. One's going to have to be, it's going to go 3 and 1. So I'm going to put the 3 here and the 1 here. Let's check it. Outer, inner, that's a terrible x, inner, and that does give me positive 2x, so that's good. Okay, and I'll separate that out, either this or this. Ah. Solve both sides. And again, if you're not doing it this fast, don't worry about it, just as long as you can get there eventually. Okay, so we have two answers, x equals 1 and x equals negative 3. So let's see which one makes sense. Now, if x equals 1, my sides are going to be 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. So those are all legitimate values for a length. But on the other hand, so my sides would be 3, 4, and 5. Now, if my sides were negative 3, or if x was negative 3, my sides would be negative 1, 0, and 1, which is clearly a terrible idea. So I could say, alrighty, this is x, and those are the sides of my triangle.